Welcome again to this channel, my friend. This is G Solutions, where we present solutions for your needs. Today we are going to discuss more about the circuit analysis, Thevenin's and Norton's theorem, and I am going to show to you how to solve these four types of circuits. According to the problem, we are to determine the Thevenin's and Norton's equivalent for each of the circuits shown below with respect to terminals A and B. For letter A, get the Norton's and Thevenin's equivalent of these four kinds of circuit. For letter A, we are dealing with this, and this one we will get the E Thevenin's and R Thevenin's and also the I Norton. Actually, this should be the value of these circuits. This circuit diagram, which is A and B, this is your R Thevenin's and this is your E Thevenin's, and the current is here. This is what we call the I Norton, I sub n. So we are going to solve for that here. To get E Thevenin's, actually what will be the voltage at VAB? So that is the E Thevenin's. And what will be the resistance at RAB? If you will notice, your VAB is equals to your E Thevenin's. So in this case, if you're going to get the voltage at AB, by inspection you will notice that you will just be having a 6 volt for this, because this one doesn't have a voltage. It will only be 6 volts. So your E Thevenin's is 6 volt, the value of this one. For your RAB, which is your R Thevenin's, since that we have here in the circuit diagram a voltage source, we have to apply short circuiting this voltage source. And when you're circuited the 6 volt, 3 ohms will not anymore be in account, so only 2 ohms. So therefore your RAB or the R Thevenin's is only 2 ohms. That's it. So to be able for us to solve for IN, we just apply the Ohm's law. So that will be E Thevenin's divided by R Thevenin's. So what's that? That is 6 over 2, and this is equivalent to 3 amperes. So that is the Thevenin's and Norton's equivalent of this circuit A. Now for letter B, we are dealing with this one. The same thing, we are going to get the E Thevenin's, that is the base of AB. So what will be the value of the voltage at VAB? Actually, that is the voltage of 3 ohms. So you'll notice that 6 volt is covering 2 ohms and 3 ohms, and then we are only getting the voltage at 3 ohms. So we apply here the voltage divider theorem. We say 6 volt is 2 covering 2 and 3, so that is 2 plus 3, which is equal to the voltage divider theorem. We are setting up the ratio. So this is VAB, or the E Thevenin's, is 2 3 ohms. From here we can solve for our E Thevenin's. Okay, so what will be the result? That is 6 times 3 over 5, and that is 6 times 3 over 2 plus 3, that is 5. So that is 18 over 5, which will give us 3.6 volts. And for your R Thevenin's, again we take the short circuit of 6 volts, so this will be shorted. What do you notice? This one will be in parallel. So R Thevenin's is actually the R equivalent of the parallel resistor 2 and 3. So that is 2 times 3 over 2 plus 3. So what is the result? That is 6 over 5. 6 over 5 is equal to 1.2. Okay, this is 1.2 ohms. And then for your I Norton for the current, you just again apply the Ohm's law. So that will be 3.6, that is the E Thevenin's, over the R Thevenin's, which is 1.2, and it is giving us 3 ampere. So that will be the equivalent Thevenin's and Norton's of letter B. For letter C, so here given here is a current source 6 ampere. So we have voltage source here, current source. To be able for us to get the Norton's and Thevenin's equivalent, we can observe this circuit that this will be a total current going through this point. This is the node, and this current will be divided to these branches. Okay, actually this part we can know that this is already your I Norton, and also another current here, 2 ohms. I can name this as I sub 2. Okay, so that's it. Now, and since that we are having this kind of thing, we can apply here our knowledge in current divider theorem. So we have applied here the voltage divider theorem, and here we apply the current divider theorem. So to be able to get the I Norton for the current divider theorem, so we are looking for I sub n here, this one. So that is equivalent to the total current, which is 6. Total current here is 6 amperes, and you multiply this current to the resistor that this current is not passing through. Where is that? This resistor, so that is 2 ohms, and that is divided by the summation of this resistor, so that is 2 plus 3. So we are going to solve for this. This is 2.4 ampere. Now if you are going to look for I2, again you multiply the total current, the resistor where the one that you are looking for is not passing through, so you can multiply this total current to 3 and then divided by the addition of the summation of these resistors. Okay, that is the current divider theorem. So you already solved for I Norton. Now for your R Thevenin's, since this is a current source, instead of short circuiting this source, you have to open circuit this source. So when you open circuit this source, you will notice that 3 ohms and 2 ohms will be in series. So the R Thevenin's equivalent to 3 plus 2, so that will give you 5 ohms. Okay, so applying now the Ohm's law, we can solve for the E Thevenin's. So E Thevenin's is equal to the, by Ohm's law, that is the current, which is 2.4 times the resistor, which is 5. Okay, get your calculator, it will give you 12 volts. Okay, now let's solve for letter D. So letter D. Okay, so letter D is here. Again, it is a current source. The current will be going to here, this 6 amperes, and when it comes here, you know the nature of the current, it goes really to those whose branch has a lesser resistance. Okay, so this is a branch and this one has a branch. So what is the resistance of this branch? It has no resistance, it has 0 resistance. So all of the current will flow through this part. So there will be no current flowing here in 2 ohms. Okay, so that will, this part is your I Norton, and this part is this one. This is another current, say this is I sub 2. So there will be no current here, the current will just flow here. So what is the value of this? By inspection, all of the current is flowing here, that is equivalent to 6 amperes. So I Norton is equals to 6 amperes. And then we open circuit this one because this is a current source, so this will be left hanging, so your AB will only be 2 ohms. Okay, so this will be your R Thevenin. So this is 2 ohms. Now to get your E Thevenin's, you just apply Ohm's law. So that is 6 times 2. So the answer will be 12 volts. So this is the Thevenin's and Norton equivalent of each circuit. Thank you.